it's simply a TV card that you can buy anywhere on the internet. On the wiki, there are a few lists of cards which were better than others. But in general, if your card is supported on Linux, you can sniff your cable neighbors. There's only one downside on this, is that you can only see the downstream. Why? Simply because the upstream, it's like that funky TDM, QRM, and weird combination. But the downstream, well, it's enough data, a lot of data actually. Also, I'd like to try USRP, but it's kind of expensive, and I'm afraid that if I buy that thing, my girlfriend won't see me again. So I think it's possible. I just have to try it out. And also DOCSIS 3, that uses multiple frequencies, as I said before. So you'll need more than one card. However, I haven't had access yet to a cable with DOCSIS 3 enabled, so I don't have support yet in my tool for DOCSIS 3. But if you have multiple cards, if you have access to DOCSIS 3 network, and if you give me access, I should have it in no time. All right. So I developed a tool for that because it's nice to sniff packets. You got like 5 megabytes per second, and you're like, okay, what do I do with all this data? You start Wireshark with your 1 gigabyte dump, and it takes forever to load. You try to search for something. Well, it's too slow. So I decided to go the hard way. So the easier way would just be to give some rules, dump this, dump that, and put everything on files. And that's what I've done. The way it works is that you simply select an input module. You say DOCSIS or PCAP because you can read from files, whatever. So, but in our case, we're going to focus on the DOCSIS one. Then the packets are processed and matched using rules that you specify, like TCP port 80. Port 21 or UDP and RTP. You can really do a lot of things. Once those rules are matched, the helper and contract modules are going to take place. The hard thing here was that you got lots of packets, but for example, you got TCP packets, they cross each other, etc. And I had to put this all in a nice way, one after the other, so I could simply take those packets, dump it in the file, and done. So that's done. And then the targets. So it's 3-step. Input, then rules match the stuff. Helper, there's a bit of magic there to make sure everything is fine. And then it sends that to the target modules. And the target modules, well, they do dump the images out of the HTTP stream, dump the RTP, etc. And of course, there's a telnet and XML RPC interface available. Let's talk now about the security concerns. So privacy, well, we're all concerned about our privacy. Of course, if you can sniff the packets, you can sniff everything that people download. So as I said here, reassemble all the streams in real time, extract everything, the main. Of course, since there is a phone plug on your modem, well, that voice is going to go somewhere. Well, it's going to go on the cable. And where does it end? In my TV card. So I just listen to it. IM conversation, let's say, do you guys use Facebook? I don't, but if you use Facebook chat for everything, it's both ways. When you type something, it's sent back to you. So you see the whole conversation because it's all in the HTTP stream. Also, all the images that people go and download. I found out, I was like, let's download and look at all the images that people go and see. And I was kind of surprised because I found out there were a lot more gay people than I expected. And I decided to stop that. Yeah, that was funny. Your own neighborhood? My neighborhood, but I don't know them. So yeah, of course you can sniff. You can find out other stuff like the Google search that people are typing. Because that nice auto-completion thing you type and it gives you back everything. Or yeah, the Facebook images. Well, I said that already. I got a friend who's got like. Yeah, that's funny. He tried that once to just dump all the images from Facebook, and he's got a screen. It's like, oh, look at my friends, and every second he's got a new picture coming up. That's cool. So what can you do about this? Of course, use a VPN tunnel to a trusted endpoint. So, well, you'll just encrypt whatever is in that endpoint in your cable modem, but at least that I won't be able to sniff you. And use encrypted protocol, SSL things. But, yeah, as we've seen, SSL is kind of flaky nowadays, so I'm not sure it's a good idea either. And, well, the best thing would be that the ISPs just enable BPI. Please do it. If you are an ISP and you are in this room or you're listening, just please enable BPI. It's so scary. All right, so there are some more fun stuff we can do. Impersonating. Well, you can simply, your modem, it's a stupid Ethernet bridge, right? So let's say you sniff all the connections on your PC, and you got one TCP packet. Oh, well, you can forge it to TCP reset, send it back through your modem, because as long as it's got the right MAC address, the right source MAC address, the packet is going to go through, right? So the IP address can be whatever. It's not going to be checked by the cable modem, and poof, that's it. You can, well, if you're like on Monday morning and you want to download faster and you see that everybody's using BitTorrent as well, just kill them all, and it goes a lot faster. Or if you like, that no MSN day, well, TCP port 181563, reset, poof, bye. Yeah, that's funny. You can also use someone else's IP address. There's a very cool thing with Windows. There are a few, but there is one that its firewall, it just drops everything. And in this scenario, dropping everything is a security problem. Why? Because if I come with my modem, or I take somebody else's IP address, and with some kind of funky configuration, you start sending packets with that IP address from your modem, from an ADSL modem, from anywhere on the internet. The packet, so let's say you're in the street, cable, TV cable, plug your USB digital card, use your cell phone, sends packet with an IP source of somebody on the cable, and that packet is going to come back over the cable. So if you want fast download, spoof that IP address, send all your stuff via the cell phone, and retrieve everything from the cable. This is also not good because, of course, you can do whatever you want. You can, I don't know, all these things, they're not nice. So if you have a cable modem and if you drop everything, just try to send TCP reset or, ICMP unreachable for UDP streams because, of course, I could tunnel something and again. Again, the workaround for the ISPs, enable BPI, please. Some funny stuff here. SNMP tricks. All right, so, well, the modem replies on, there is an SNMP server on the modem, but, well, it's not accessible by you, of course. If you try to send a request with the public community, that won't work. So what do you do? Well, you sniff, and at some point, the ISP is going to check what's happening in your modem. For example, it may want to tune a bit the time slots, or make sure you got the right power levels, etc. But that's easy. Once you got that single packet, it contains what? The IP source, and also the community. So, well, what is the modem again? A stupid bridge. You send it from the Ethernet interface, and the modem is going to reply to you. All you have to do is sniff the source IP address. And, okay, now that we got access, what can we do?